Howdy, we're going to learn how to name ionic compounds. Remember, when I say an ionic compound, I really mean an ionic bond. There's two different flavors. There's the type 1 ionic and the type 2 ionic. The type 1 only has one oxidation state, and the type 2 has more than one oxidation state. If you're wondering right now what an oxidation state is, remember it's just the charge, but you also may want to check out the previous video on oxidation states. So let's review what an ionic bond is. An ionic bond is a mutual attraction between a metal and a nonmetal to make an ionic bond. Let's get this out of here. So the metal is always going to be positively charged, and the nonmetal is always going to be negatively charged. Okay, this forms a mutual force of attraction because the positive and negative will actually attract to each other. Once they attract to each other, they form the ionic bond. They don't change charges and they don't exchange any electrons. They're only attracting to each other by this very strong attraction. These positive and negative charges have special names. The positively charged is called the cation, and the way to remember that is that a cat has paws, so it's positive. The negatively charged is going to be called the anion. I don't have a memory trick for that. Just remember that the cation is positive, so the anion is negative. The anion will always be the nonmetal, and the cation will always be the metal. So how do I remember the charge? All you have to remember is go to the periodic table. So the periodic table, this one is in my classroom and will be available for your reference, and it is super duper handy. What we see here are the common type 1 cations. So those are the group 1 and the group 2 cations, or the group 1 and group 2 elements. You'll notice here that these also only have one charge. These transition metals will only have one common charge. The only one that's really necessary to memorize is that aluminum has a positive 3 charge. The rest of them you can use as a reference. So remember that all of these will have a positive 1 charge, because they're in group 1, and that all of these will have a positive 2 charge because they're in group 2. Aluminum will have a positive 3, it's in group 3. Now the anions on the other side, the anions are the nonmetals. These are most frequently your anions. The noble gases will have a oxidation state of 0, and they're not pictured here. The halogens will have an oxidation state of -1. You can see these all have -1. And these, group 6, will have an oxidation state of -2, and then these will have an oxidation state of -3. So think of this as almost like a football field. If this were your 50-yard line and it was split in half, it kind of decreases just going outwards. We're kind of skipping the transition metals because the transition metals are for another video. They can have 2 different oxidation states. Your tests and quizzes will ask you to know the chemical formula and also the chemical name. The chemical formula is the symbols, and the chemical name is the words. These two can be used interchangeably, and they mean the same thing. Just one is in symbols and one is in words. Let's do some examples. I'm going to swipe this out, move this up, and put these down here. So I have 4 chemical formulas and I want to know their chemical names. So I need to look at AgCl. I could look at this periodic table, but it doesn't actually show me the names. I see that Ag is a type 1 cation, and then Cl is an anion. So I know that I can look at this periodic table, which is available in my classroom too, and see that Ag is silver and that Cl is chlorine. So this is going to be silver chloride. I didn't change the cation or the metal, but I did change the anion. I changed the last name or the last part of the anion to "ide." I'll always have this "ide." So let's look at ZnO. That is going to be here for zinc, and then O for oxygen. So that is going to be zinc oxide. Here I have CaBr2. So now the question is, what does this 2 have any effect? And the answer is no. The name will still be the same, even if I somehow magically covered up the 2. So this one will be calcium and bromine, so that means that it will now be calcium bromide. This one here is SrF2. So again, the 2 doesn't make a difference. And I know from my periodic table that Sr is strontium and the F is fluorine. So this is going to be strontium fluoride. Notice that these all end in "ide", and all ionic compounds will end in "ide", I-D-E. Your tests and quizzes will have me give you the chemical formula and you know the chemical name. But I will also give you the reverse process, where I will give you the chemical name and you need to know the formula. An example of this would be something like potassium iodide. So let's get rid of these two and let's try to break down what potassium iodide is. Potassium iodide is simply just potassium and iodine. To do this, we'll need to know their oxidation states. So note where you are in the video right now. I want you to be able to come back to this because I'll be referring to this a lot. We're only looking at the group 1, the type 1 cations right now, and the anions. So we're going to be looking at potassium, which has a positive 1 charge. I know that from the periodic table I just showed you. And that iodine has a -1 charge. You do not have to memorize this first year chemistry, just use the reference sheet. So the positive charge, +1, and the -1, the ones are understood. So the +1 and the -1 will attract to each other, so they will actually form potassium iodide. This forms a net charge of 0. The net charge is going to be the positive and the negative added together, so that +1 and -1 equals 0. Another example is magnesium chloride. So remember, this is just magnesium and chlorine. So let's get their oxidation states. Magnesium is a +2 charge because it's in group 2 on your periodic table, and chlorine is a -1 charge. It is in the halogens group. Okay, so then we have a +2 charge and a -1 charge. So if we add these two together, we will not get a net charge of 0. +2 plus -1 doesn't equal 0. So we're actually going to need two chlorines for this to work out. I need two negative charges to balance out my two positive charges. Another way to show that is by doing what I call the crisscross method. You can take magnesium 2 plus and Cl minus, and now circle their oxidation states and crisscross. Crisscross. When I do that, the positive 2 charge will now come down here and be a subscript. The negative 1 charge will now come down here and be a subscript. We'll drop the signs so that we get MgCl2. Sodium sulfide will now have sodium plus sulfur. So this is sodium is a positive 1 charge, and sulfur is a 2 minus charge. Now I'll still need to do the crisscross method. And I will get Na. The 2 will now come down here to where the arrow points, and then S, and the 1 will now come down here, and the 1 is now understood. So this would be the correct answer. All of the type 1 cations will work out this way, and without any extra Roman numerals or anything special. But I'll give you some more examples. Aluminum sulfide is just aluminum plus sulfur. Aluminum nitride is aluminum plus nitrogen. Aluminum has a 3 plus charge. Nitrogen has a 3 minus charge. I can see that there's a 3 plus and a 3 minus. So they will cancel out and make a net charge of 0. So the final answer is simply AL.